Okay, in this next series, video series on the geometric sequence lecture, same exact problem as before. We had the terms 2, 6, 18, 54, 162. But what we want to do this time is find the 27th term of the sequence. And so what I would do is say, okay, well, we already have the function. So let's write down the function again here. So we have a of n is equal to 2 times 3 raised to the n minus 1. So in Desmos, what I'm going to do is I'm going to create the function a of n equals 2 times 3 raised to the n minus 1. I got to stay up here at the top. So this is the tricky part. So in order to put this up here at the top, you're going to have to actually put it inside parentheses. And then I want to call this function with the 27th term. So what that means is I'm going to say, okay, we're going to, on the next line, we're going to do a of 27. And it's going to automatically send that calculation in for me. So a parentheses 27. And it's going to give me some weird looking number right now because we haven't really worked with the scientific notation. But our answer for this one, we'll just round it to the nearest, let's go with the nearest thousandths on this one. So this would be 5.084 times 10 to the 12th. So this number is getting massively large. What actually happens is that decimal would move 12 places to the right. And so you can see it's going to be a massively large value that we see here for this geometric sequence. Okay, and the next one we have 512, 128, 32, 8, and 2. So again, if we are evaluating for a term in the sequence, I'm not going to use recursion to do this. What I'm going to do instead is just create the um, explicit form of the equation. So for this one, it's going to be a of n equals 512 times 1/4 raised to the n minus 1. Now, keep in mind, 1/4 is also, get it where I can write it in here. 1/4 is also 0.25. So we can use the decimal instead of the fraction here. So now I'm going to evaluate it for the 12th term. So I'm going to go a of 12 equals, and we're going to see what that gives us here. So let's go back into Desmos. We're going to modify our function. So 512, we're going to put 0.25. And now I'm evaluating for the 12th term on the list. And so you're going to see that it's an extremely small number. I'm going to have to go several decimal places on this one, but 0.0001, let's go with 22. So you can see that it is getting extremely small. If I wanted to, I can even convert this into its fraction so you can see what this pattern is. This is going to give me 1 over 8192. So that's a lot more precise than the decimal because you see I left off quite a few decimal places.